Vamos ver se vai dar. Que ele quer que eu reinicie. Não, deu.
Ok. Ah, acho que tem que permitir, né? Ou não?
Permite o quê?
É, permitir.
Ah, gravar. Tá.
Looks
Tá
great.
vendo que iniciou.
Yes. Marcela, thank you for joining us. Whenever you're ready,
Okay.
please introduce yourself.
Okay. So good morning, folks. I'll be talking today about adaptive testing. I am nervous, so if I'm failing, I'm sorry, but I think I'll get along. So here I put this slide for give you some context on why I'm giving this presentation today. First of all, for those of you who doesn't know me, my name is Marcela Sanseverino. I'm from Porto Alegre, Brazil. My institution, I guess it's the one I'm affiliated with is PUC-RS. And here in Gemini, I'm working on the mental health and psychometrics like group. And João asked me to join the Drink project, where our goal now is to combine data sets to further validate the instrument, which is the drink instrument. I actually now don't know if everyone is familiar with it. And then the goal is to apply this adaptive testing on the drink instrument. But the thing is that I heard about adaptive testing before, but I never used it. And I didn't know much about it until like 2 or 3 weeks ago. So my goal today is to present to you what I've learned so far so we can learn it and try to implement adaptive testing in our research and analysis, and to check if anyone has experience with adaptive testing. And if you can share advice, it would be greatly appreciated. Por que não tá passando? Okay. So the topics I'm going through today is a historical overview, very little, not very deep, uh, of adaptive testing. And then I'm going to talk a little bit about response theory and its key concepts for adaptive testing and why that's important. And then I selected two papers that used IRT and adaptive testing today so we can learn from like the practice of how this method is used. So beginning a historical overview, but first talking about a little the concept of adaptive testing, which is very simple in a first glance, that is adapting a test to the ability level of an individual test taker. So the goal is actually to reduce the number of items and give items that match the ability level of the person taking the test. So adaptation like this predates formal psychometrics, and when oral examiners and diagnostic interview were already selecting questions based on the previous research. So the most famous test so far at this point would be I don't know how to say that in English, but Binet test, which he had explicit item selection rules using also the mental age of the examinee as a difficult scale. So he would select the item according to a previous response, and the first item was selected according to the person mental age. And then if the person got, I think, 5 questions wrong, the test would stop. The main problem, so going along, short after that came the World War II. which they needed to apply to gain in scale. So they start applying paper and pencil tests in groups. So this made it possible to apply a test to a large population, but we lost this adaptation process that would have to be a one-on-one test. The main problem is that we had to have then items that are either too easy or too difficult and ended up wasting the respondents' time, and it would reduce accuracy. I don't know how to say that in English also, so. Uh, but what made possible for adaptive testing to return was two main things. The development of IRT, item response theory, which has separated parameters for person and for items, but in the same metric scale. And also, computers were then popularized and more accessible, which could uh, uh, which was able then to select items in real time. So around the 60s, we have the consolidation of Rush models, which is one of the like famous models in IRT. And we had theories before that, but hash model would set a stone on history. And then in the 80s, we have computer advancing. And in the 90s, we have the first known application in large scale of what now is called CAT, which is computerized adaptive testing. So new challenge has begun with that because now we have to worry about database security, exposure control, content restriction, and response time. So all of this are new, like almost variables also in the adaptive testing. So key concepts of IRT. This slide doesn't have any reference because it's like voices of my head trying to make us all in the same page. Um, so uh, so you can understand what we do in psychometrics. We try to measure a latent trait that explains the construct being measured. So the latent trait can be knowledge, health or illness symptoms, or a ability. Ability is easier to like understand maybe. So we have a continuum ability that goes from easy to difficult. And then we have people with this ability. And we expect that most people, this is like a Gauss curve, okay? That most people have a medium ability of the construct we are measuring. And then if we go to the extreme, very easy or very hard, we would have fewer people. So just keep in mind that this can be either knowledge of like history, or it can be a depression level, or it can be alcohol use. And here we have a little more complex figure because we have the curve of the test, but we also have the same, like similar curves to each of the items, all in the same metric scale. So with one item, I can already estimate the level of ability of an individual. And here I can see that item 2 is easier than item 3, and that item 1 is the hardest because I have to have a lot of this ability to answer this item. So here we have some, sorry, it's just because you are blocking. We have the things that make IRT useful to adaptive testing. So we have a conditional standard error that can estimate precision for each person being evaluated. we have the data level that allows comparison of respondent who received different items. It enables CAT to stop the test as soon as the desired precision is achieved. So I don't need a lot of items. I just need the items that will give me the precision I need. And it identifies where on the continuum, so where in that where in that Ashley, help me out. The theta in that arrow, the instrument measure effectively. Okay, so here we have the parameters that you will see when you read a paper that used IRT. So of course the theta, and we usually assume a standard normal distribution, so like the Gauss curve, where the mean ability is 0 and the standard deviation is 1. The parameter A, which is the discrimination parameter, that is measured the slope of the item characteristic curve. So it measures how well the item differentiates between individuals at the level of its difficulty. And then we have the parameter P, which is the difficulty of the parameter difficulty, which is the level of the latent trait, the theta, at which the probability of a specific response changes. So each Likert category generates its own unique threshold. So with my ability level, how likely is that I respond 2 instead of 1, 3 instead of 2, and so on for each point of the Likert scale, that usually is 5 points. And then we have the grade response model that came a bit after the Rush model, but it took a step forward because we can use now polytomous models designed for Likert scales, for example, whereas the Rush model would be for dichotomic items, so yes or no, true or false response. Each response category corresponds to a specific distribution along the data continuum. So here we have the parameters that are very useful for the adaptive testing, which is the item information function, that is an index of precision that each item provides at each value of theta. So how much of an information does an item is capable of giving? And then we have the test information function, that is the sum of the first parameter that I just said. So it indicates where the instrument measures well or poorly along the continuum. And then we have the conditional standard error of measurements that I already talked about, that varies by respondent, allowing definition of individualized stopping criteria. And we have to say that they are fundamental related, as the information is the inverse of the standard error measurement, okay? So the greater the information, the smaller the standard error, and the higher the precision. So how does computerized adaptive testing works? We have an initial estimation of the data, which usually we go by the mean of the population we measure. And then a first item is selected based on that measure. But we can also have a standard item to make this initial estimation. And then the respondent will respond, and the data would be re-estimated according to each response. So the next item will give the maximum information given the new estimated data. So this is repeated until the stopping rule is met. And the stopping rule are usually one of the two or the both or the two rules, which are define criteria of a standard error. So I want standard error to be less than 0.3, for example. So once I reach 0.3 or a lower value, the test will stop, or a maximum number of items is reached. So like I want this test to be no more than 30 items. So once the participant responded 30 items, the test will also stop. Summing up, so that is very clear. Each respondent receives a unique set of items calibrated to their specific level of ability, achieving comparable precision with significantly fewer items. Here we have like a graphical illustration of what I was talking about. We have the item selection in the item pool. The item pool is always already calibrated, so I know which level of ability each item measures. And then once I estimate the data, I will then recover items from this original pool. But we can also have shadow tests that once I know the ability, the computer makes a shadow test, and then the item selection is like optimized because I will have already selected the items that is real like relates to this to the person ability. And we also can have family of items in the big pool, so we know each items belong to the same family. So once I'm making the test, the test will know which family will have the similar items. I don't know if that makes sense, but more or less. So now I'm going to talk a little bit about studies that already use this adaptive testing. And I will be focusing on the methods and results of this article, so I'm not going to present them in full, okay? So the first example is from 2011, and it's about an instrument of career confidence inventory that has originally 190 items in 6 different subscales. And alpha between the subscales varies from 0.9 from 0.94. So first, they perform exploratory factor analysis and a confirmatory factor analysis to check the dimensions and the final selection of 100 items. So here they dropped 9 items, but they kept the 6 subscales. They used an IRT unidimensional model, that the one we talked about, the graded response model, and the R package they used was this LTM. So they had to do this for each of the subscales, okay? It's not one test for the 6, it's each test for each subscale. And then they perform an adaptive testing simulation with this software using the parameters A and B to generate with the IRT. Generated with the previous IRT, sorry, assuming a standard normal distribution. So they simulated examinees with a known data, one at a time selection, minimizing standard error. And the stop test rule was when the standard error measurement is achieved or it's lower than the decided value. Their goal is to see how many items will be necessary to achieve the decided standard error measure. Okay, so here we have the results. Again, I'm not gonna get deep into it. I just want you to see that here they define 4 different standard error. And the higher the standard error, if you take one scale, for example, the more numbers are more items are necessary to be administered to reach this higher precision, lower error. So we go from like almost 2 items per person until 10 items per person. But if you compare like with the 100 items that were administered before, we have much lower number of items. But here is uh, it's a mean of the number of items administered to each examinee, but we don't know uh, how many items are necessary to different data levels. So they put these 2 graphics here so we can see the distribution of the number of the items that were administered and the data level. So each one of these points, dots, are a person with their estimated data level and the number of items administered. And for this test, we can see that the lower the number of items needed to reach the precision, the closest to the mean theta value. So like people that are on average, they need fewer numbers of items. If we go to the extremes, like people with higher of this conventional career thing, or lower in this subscale, and this subscale is the same, they need more items to reach the precision they wanted. Okay? So to sum up, they could reduce the 100 items to almost 50 items for each application when the standard error of measurement sets in 0.440. Their reliability is around 0.93, which would be the correlation of the real data and the cat estimation. So comparing the old test, like the formal test, with the computerized test. And here is the amount of time they estimate would be reduced if administering a cat instead of the whole test. So they estimate that the time reduction would be around 50% of the time of the respondent. Okay, let me just drink. Sorry. So going on to the second example, we have, so I searched a research that is already on alcohol use. So these authors developed and validated an item bank for alcohol use disorder. So according to the authors, the alcohol use disorder, AUD, instruments didn't cover the whole DSM-5 criteria, and no adaptation, to the patient's alcohol use disorder level of consumption. So they selected 5 already known and validated scales. These 5, I'm sorry, I don't know these scales, but in case anyone know, it's these 5 they selected, and they used that to create an initial pool of items that was reviewed by clinicians to cover the 11 criteria. Their goal then was to build an item bank of AUD screening and derive the computerized adaptive testing version of this AUD that they called then the CAT AUD. These are the methodological steps they took. So they created that initial bank, item bank, reviewed by the clinicians. And then they test the unit dimensionality with this exploratory factor analysis using the SPSS 21. And I don't know why they did that, okay? But that's what they did. And then for the IRT model selection, they used both graded response measure, which is the same of the last paper I present. And they also use the partial credit model, which is when we have a mixture of items that have dichotomous and polytomous response categories. They use these indices to the model fit, and the item fit is this that I have never seen. That's why I put exactly what they call. But the main thing is that they use this criteria to consider if the item considered to be poor item fit. So they would exclude items here in this stage according to the fit. They use the discrimination parameter also. Items with a 0.7 or lower were then excluded from the bank. And then they did this differential analysis investigating both gender and region with an R2 higher than 0.2, the items were excluded. This means that if the item has a diff higher than 0.2, it measures the ability in different ways for male or for female, or for people in a rural region or a non-rural region. And then they excluded this item, so the bank would be like universal according to these parameters. And then, like this, they reached the final cat odd item bank. I forgot to put here the number of items they had in this this final bank. This final bank here. But I think it was around 100 items also. So they did then the cat Audi simulation, and the initial item selection was a random pick from the final bank. And then the item selection algorithm is the item with the maximum feature information, MFI, based on the participant current theta estimated from this first random pick. Scoring method they put here is expected a posteriori, and assumed standard normal distribution was assumed. And the stopped rules was, they used both rules that we talked about before. So they fixed the standard error measurement in 0.32, and they didn't want any test to be higher than 35. So if the test didn't stop because of this standard error, once the person examinee reached 35 items, the test would stop. So here we have just this table I wanted to present to you, because they used the audit to like compare reliability between the cat and these two that are like the gold standard of the literature. And we can see that the reliability is higher for the cat IUD. Here, sorry, here we have then the curves of the estimated theta, comparing the full length in red, and then in blue we have the cat AUD. So you can see that the lines almost completely overlap, just apart from this point here. So we can see that the ability level, or actually the consumption level, is the same of both tests. But they make a reminder that people in the full length test responded like 100 items, while the cat audit test, they respond just at least, or no, not up to 35. Then this is also estimated, okay, from the simulation. And here we have the number of items administered by individuals and their data levels. So once again, the dot spots are one person and their data level and the number of items administered. And we can see that the lower the consumption, the higher the number of items necessary to reach the standard error estimated of 0.32. And the higher the consumption, the lower the number of items necessary to reach that same precision. And here we have the relation of both the, so just let me take you away. So here we have the real data collection on the left, and on the right, we have the simulated cat data. You can see that the curve is much more smoother on the real collection, but it's also very similar with the simulated data. So here we have in blue, in both graphs, the standard error that we can see that it diminishes according to the data level. And the red is the information that IIF index that I told you about. So the higher the consumption, more information the items the test usually gives. So here I just put the two graphs, so like a reminder that we have to be careful on which construct we are evaluating, so we can estimate the number of items, because here we have lower items in the middle of the curve, like in the average data, uh, when in odd in AUD, we have lower number of items in higher data levels. Okay, so this means that AUD, I thought I put in the next slide, but this means that this AUD bank that they generated are useful to select and screen for people with higher levels of alcohol consumption, or with a large probability, a high probability of developing or already having alcohol use disorder. So if you don't consume alcohol, or you're not in the zone of danger to develop or to have also present this disorder, this test will not be a good fit for you. So, like, summing up to my goals with this presentation, I was thinking about my SAP to the drink project, and I reached the conclusion that maybe what we should do is actually to create shadow tests according to different data, because for what I understood, reading about adaptive testing, we cannot uh, do this with tablets. We have to have computers. And this may be a barrier when we go like in hospitals to screen patients, for example. So my idea is that maybe we should try to do the multi-stage testing, which is very similar to adaptive testing, but the goal here is to have stages to reach the test that is more is closer to one's ability. So I will have a set of items to estimate a patient data, and then according to this data, I would administer test one or test two, which would meet their level of ability. In this multi-stage testing, we can have more stages or fewer stages. We can have more items here or lower items here, and we can also have more than two tests. This is just an example. But I think our focus may be more to this. But the literature is much more extensive with the computerized adaptive testing than with multi-stage, but I think it's a challenge that we should seek. So my goals with today's presentation and my questions for you now are, what can we learn and implement of AT in our research and analysis? Again, if anyone has experience with adaptive testing, do you have any advice? And also, I was thinking about what social demographic variables should we be aware or careful with when going into this analysis, as the Liam study showed difference, sorry, differences from male, female, and regions in their country. So that's it. Thank you guys for hearing me. I hope I didn't bore you. I think
Not at all, Marcela. Really cool presentation.
Bonjour.
I'm sorry I had joined a little bit late, but it was nice to catch on the articles you showed and their approach. It's really cool.
Que bom. Sorry.
Can you
That's it.
can you speak on this difference you talked about on the multi-test versus the computer test? Are
Yes.
they, so let me think. In this multi-test, would the patient actually, let me go back. So for the multi-test, how many questions you think would be necessary to estimate what test the patient would need to take in the second stage? Or is this something that is going to depend on each individual psychometric properties?
Actually, the thing with multi-stage test is that we don't know before we simulate and test. So on my mind, what we would have to do is calibrated the items we already have of drink, and then like run simulations to check which items would be fitted for the selection, like that first stage. Uh, and we should try to reach the smallest number of items so it can be feasible or doable, I don't know, on like an emergency room, for example, or in posto de saúde, or in a health environment. And then so we'd have, and also the tests, the lower the number of tests, the better. And that will also depend on our goal. For example, in the second study that I showed, uh, their goal was to really select and pick up the pint out, sorry, the people that are in danger of an alcohol use disorder. So their goal is not to evaluate if you're not in that area. So their test was really good in doing that, because if you see on the graph, sometimes with two items only, you could already select, okay, this person probably has alcohol use disorder and with good reliability. But if you had low, like if you're not there, so it kind of depends on what we want to achieve, and then we have to run simulations of this so we can know how many items in the stage one and how many tests in stage two.
Okay, that's great. And on the second stage, so would it be that each person would have a different set of items, or
No.
would it be that based on the simulations, everyone would respond to the same items on stage 2?
Everyone in the same level of ability would respond to the same set of items. So if we have like the same alcohol usage, probably we will answer to the same shadow test. But if we have different alcohol uses, then probably we will receive different tests.
Okay. Okay, makes sense. Thanks.
Thank you.
Any more questions, comments?
I'd love to hear if anybody has some inputs. Feel free to go ahead, Guillermo. But I was redirecting us to the questions that Marcela shared about other characteristics, demographics that maybe should be considered if anybody has, especially maybe if they're not as obvious as the ones that she's already mentioned, or maybe special to your country, your region, your study population that anyone wants to share. So think about that, but Guillermo, go ahead.
Yeah, I have, first of all, when you say you need a computer, is because you need a stronger software, or if we do like, we have an outside server and we do that on a site or on an app with the cloud, we could. I don't know if I can make myself clear. I don't know enough about computers to formulate my question.
I was curious about that too, because you said computer and not tablet. I think, but to me nowadays, they're basically the same. So can you clarify what's the difference?
Yeah, I'm not completely sure yet, because I'm still approaching this team, but I think my guess would be like they need maybe how do you say that? Memória de trabalho.
Yeah, like working memory.
Like the work,
powerful computer.
The power of the computer to perform the tests in real time.
Yeah, so probably what Guilherme was pointing out, if we could make this into like a website, like a server, and then just use the tablet as the interface with the internet, I think it should work. We had issues before, I mean, for some stuff, because tablets usually do not run Python, they not run R, do not run any type of programming language. So they can just be the interface for the ease of, you know, if we take this to a patient, we don't need to take a laptop. We just take a tablet. They can respond while they're waiting, while they are on their room or something. So yeah, that's interesting. I'm curious to understand as well, Marcela, in terms of how you know, how computationally expensive the simulations are at the real time. Because if you think about it, like for things like Drink, where we have 50 questions, I'm assuming it could get quite heavy if you think on the possible combinations of tests. So a given patient would have like 50 factorial combinations, if you think about it, probably. So it's a lot, yeah.
It is. So the shadow, I think the shadow approach, the shadow test approach, and like thinking about now computerized adaptive testing, this shadow test and the families of items that I showed the illustration, they might reduce that a little bit, because then you select fewer items, like from the 100 or the 50, we select 10 items, and then from those 10 items, we then further select. So we optimize that. I think that's one of the goals also of this strategy. So we don't pick from the whole pool of the whole pool, but we then select. But in multi-stage, then what we could do is have the paper and pencil test, for example, in a setting that we don't have computers or we don't have internet or tablets available, we would have the test. Of course, we wouldn't be able to score the person in real time. It will need a human being to check the answers and then further estimate the data based on the test. So we could like select this patient has a probability of alcohol usage or disorder or not. Does that make sense? I don't know if I respond.
We did.
Okay.
Yeah. I also wonder, for some of these computational tests, I see that I'm just quickly Googling here. There are tests with like 500 items, 5,000 items. Of course, the person is not going to respond to all of them, but
Yes.
then it is a way for you to derive questions that would maybe make more sense to that patient. They would get to the patient, to their, way of thought, or how they would answer. I remember, for instance, responding to those personality tests, like the managing skills, etc. And I remember very uniquely responding to the same question in 10 different framings. So like, what do you like to eat versus what is your favorite food versus what do you eat every day? So derivations of the same concept. So I guess that also could be an opportunity if we think that we could expand on drink to frame the questions differently or something like that as well. So yeah.
Yeah. I also read, but not deepen again, that they are starting to use artificial intelligence to generate these items also. So that's why they are so similar. But sometimes it's also helpful to have more items that are really like closely similar, so we can have different items for like the same person, especially on then on educational settings that, for example, when I went to take my driver's license, I took I took the test 2 times. So on the second time, I already knew some questions and answers. And the goal with computerized testing is maybe if I go on the second time, I would have different questions to measure the same level of ability, and then the test wouldn't be repeated.
Some of the questions that we use, especially in personality assessment, that have multiple variations of the same information, are used for lie detection too. So they'll fall in on like a lie scale, because if I ask you if you drink alcohol and you tell me no, and then I ask you how many alcoholic beverages you have a week and you tell me 4, then that highlights something that I, as the researcher or the practitioner, need to go back and address. And, hey, which is it? It doesn't necessarily mean the person lied. Somebody might have, clicked the wrong thing. And then I also wanted to touch on the piece of the tablet. We frequently in mental health practice use the tablets now to administer intelligence tests, and we'll use it as I believe it's used as the interface. It doesn't necessarily do the calculations itself. It needs to be connected to the computer to run the calculations. But it can
That
be
makes
quite
sense.
helpful. There's some really interesting information on the use of the tablets with intelligence testing out there that's come about since the COVID-19 era. And what it was is that we had started to move from the paper-based testing to testing on the tablets. And some of the tests that we were given did not look the same. And because of the way the data was presented, there was a question of, are we measuring what we're trying to measure? And one of the best examples of that would be on the processing speed and working memory tests, because on those, the goal is to answer as many items correctly as possible in a set amount of time. And on the paper version, you would get one large sheet of paper with a whole bunch of items on it, which in a way allows you to kind of pre-screen the items, even if it's subconscious. Whereas the tablet would show you one item at a time, and then it would switch to the next item. And then you run into two issues. One is that you're not pre-screening the next items. And two is that you have the refresh rate on the tablet, at which point you might be measuring the difference in quality of internet connection, or you might be measuring the difference in the quality of the tablet that one person is testing on versus another. Just some thoughts.
Yeah, no, thank you for sharing. And this is what they talk about, this new challenges that arise with computerized testing. As I understood, maybe you're not yet using adaptive testing, right? It's just testing on tablets. We also have maybe sometimes the person reaction time to answer the question, giving us some information.
Yeah, the intelligence tests are adaptive.
Okay.
And some of the personality measures are adaptive too. Most of those are still administered on the computer. But I think that that's more an issue of those developers, or those test developers moving slowly, than it is the capability of the tablet. If that makes sense. I think the tablet can probably run it. I don't think the developers are interested in paying to move something when they already have a tool that works.
Yeah.
Unfortunately.
Yeah.
One day.
Yeah.
One thing that can be relevant to the group as well is when you like you're submitting your IRB application to run and to survey patients, you usually have to provide a PDF of the or attachment of the test for them to consider what data you're collecting, etc. But with these types of tests, you really can't, because every patient is going to get a different set of combinations. And since this, so the adaptive tests are around for quite some time now, this is fine. But when you talk about using AI to generate the test for the patient, this gets really tricky. The one thing that I've heard from someone that was doing something similar is that they were having issues to set up a chatbot interaction through the IRB. So IRB was having a hard time to approve. And they actually used the argument that with IRT, so with the computed tests, adapted tests, they have a similar scenario where it is pretty much impossible for you to determine what test the patient is actually going to have, because some of these tests have hundreds or thousands of options. And that's the way they were able to get through with the IRB. So if that's something that comes up, maybe this is going to help. Yeah, just an observation.
Yeah.
All right. So thank you, Marcela, for the presentation. It's a really nice topic, really cool presentation. Thank you, everyone, for the comments. If anyone is interested in working on this field, Marcela is going to be here with us for 8 months more, I guess.
Yeah.
And she's been working, a lot of the psychometric work as well. So reach out if you want to join.
We have some other related papers that could use some help for writing and things on quite similar topics too, if folks have interest in psychometrics. You can learn with us.
All right. So see each other again next week. Thank you all for coming.
Thank you, guys.
Salam.